Number 23 and 24 just say solve. And I'm looking at this and I'm like, okay, can I unfoil this? I sure can. First is x squared, so that has to come from x times x. And then my last term is a negative 45. So my factors of 45 are 1 times 45, 3 times 15, 5 times 9. That's it. So I need two factors that add up to negative 4 in the middle, and that is gonna be the 5 and the 9. The 5 has to be a positive and the 9 has to be a negative. So I'm gonna have an x plus 5 times an x minus 9. And then you just figure out, what x is. This x right here, if x plus 5 times something equals 0, then this x right here would have to be a negative 5. So that negative 5 plus 5 makes this thing 0, and then 0 times whatever is 0. And then this one, x would have to be positive 9, because 9 minus 9 makes this thing 0, and 0 times whatever's in the first set of parentheses is 0. So those are my two answers. Now, the next one does not have an x in it. It has an x squared, but not an x. So I'm going to solve this by using the square root method. I'm going to start by subtracting 2 on both sides. That's going to leave me with a 4x squared on the left and 36 on the right. And then I'm going to divide both sides by 4. And that's going to leave me with an x squared on the left and a 9 on the right. And now here comes the square root method, where you square root both sides. And the square root cancels out the square, so you're left with an x. But then you have to remember, this is a quadratic. There should be two possible answers. So remember, you're trying to figure out what x can be. And so x could be a 3 that got squared, or a negative 3 that got squared. So you have to consider both answers on that. All right. Okay, and then moving on to 25, it says use the quadratic formula. And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you have to identify a, b, and c. And on this one, it's not in the ax squared plus bx plus c equals 0 form. So I'm going to have to subtract the 12 and subtract the 3x on both sides in order to get this in the right form. So I'm going to put the x squared first, the minus 3x second, the minus 12 third, and then that equals 0. And now I can identify that there's my a. It is this invisible 1. And the negative 3 is my b. And the negative 12 is my c. So I'm coming over here to my formula. And whenever I do this, I like to take out the variables and stick parentheses in its place. And then, I like to color code, because the color just, makes things just more pretty. Let's see, C, there's only one C, and it's going to go there. And then the B, there's a B here, and a B there, and the A. 2 A's here and there. So I just need to stick in the numbers now. So it's a negative 3 here, a negative 3 there, a 1, and a negative 12. And now it's me and my simplifying skills. So for this guy right here, if it's a minus, that makes it a positive 3, plus or minus the square root of, this is a negative 3 squared, so that's going to be a positive 9. And then back here, I'm taking a negative 4 times a positive 1 times a negative 12. So change that to an addition sign, a plus 48 all over, and then this 2 times 1 is dose 2. And then finish adding the stuff inside the parentheses, and 9 and 48 adds up to 57. And 57 is a prime number. There are no factors of 57. Yeah, you would try to find a square rootable factor, some number that goes in 57 that you can take the square root of, you know, like 4 or 9, but none of them go in there, so I can't simplify this any further. So that's my answer, and I'm sticking to it. All right, and then I got time, I can get in one more. Number 26, it says consider only the discriminant, which is the b squared minus 4ac, to determine whether one real number solution, two different real number solutions, or two different imaginary number solutions. And remember, this has to do with the graph of the parabola. There are 3 ways that you can see a parabola. The first most common way is this one, where it intersects the x-axis in 2 places. That is going to be 2 different real number solutions. The next one is when the parabola sits right on the x-axis, and that would be one real number solution. And then the third one is when you get a floater, a parabola that floats above it. It doesn't touch the x-axis at all. And that would be 2 different imaginary numbers. Now, for that one, the b squared, your discriminant, I'll just say D for discriminant, okay? From this one, your discriminant capital D, is going to be less than 0, which means negative. For this one, D would be greater than 0. And then for the one in the middle, this one would be D equals 0. You only get one solution because the plus or minus goes away, because it's plus or minus the square root of blah, blah, blah. And if your blah, blah, blah ends up being a 0, the square root of 0 is 0. And whether you add or subtract 0, you're going to get the same answer. So let's look at the discriminant. Let's see. A is this invisible 1 right here. And B is a negative 3. And C is a positive 8. So b squared minus 4ac. All right, so the C is going to go here. The B is going to go there. And the A is going to go there. So just plug and chug. This is a negative 3, positive 1, positive 8. So starting with the negative 3 squared, that's a positive 9. And then it's a negative 4 times a positive 1 times a positive 8. That would be a minus 32. And right here I can see it's going to be a negative answer. 9 minus 32 is negative 23. So I am going to get, my final answer is going to be, I'll put that in, I don't know, about, yeah, no, orange. This right here, I'm going to have 2 different imaginary solutions. And that finishes that.